Okay, we have covered the section, chapter from chapter 1 to chapter 6. So we will have our midterm exam in the next Wednesday from 10 to 11 a.m. at the same place here. Okay. Today, we're going to review your PBL report in order to help your preparation for the midterm examination. Before we review the whole content, let's take a short look on your questions and answers in Q&A. Okay, the use of isomorphism in reality. Here I just shortly added one note which was made by the professor at Yonsei University Computer Science Department that how he used the concept of isomorphism to solve his problems. And here, how can we prove cofactor expansion? And actually in Quora here, and this has the same question was raised and it was answered in here. So you can take a look, and also you will have be able to find some information from our textbook. Actually, it's based on the definition and properties of determinant to draw the Laplace cofactor expansions. And orthogonal matrix, we will cover this orthogonal matrix in chapter 6, chapter 7. So you will learn this important concept of orthogonal matrix. And yesterday, we had one university QS university ranking, and here, and also this was interesting. And linear algebra, math of 21st century. Here in Quora, there was a discussion. There was a discussion on this issue, and which seems to be very interesting. So I just added one. And Orkan, you asked me what the code and the midterm examination. And here, my answer was here. In the first page of the midterm exam that I gave you, and you saw, I gave the list of the code that we can use to cover the whole content in this course. So all you have to do is just choose the right code in it, and the right copy down on the right place in the exam. That's all you have to do. So you don't have to memorize anything. If you have done it once, then you will be able to find easily from the same code from the box that I am. And the Buck, the difference of Gaussian elimination and Gauss-Jordan elimination and elementary row operations. Here, this is a difference. Gaussian elimination is a way of solving linear system of equation AX is equal to B. After you do the Gaussian elimination to find one simple low echelon form of A, then you have an upper triangular matrix like this. So you can use a forward and the backward substitution to find all the value of Xi's. Okay, that's the Gaussian elimination. That's it. Next, Gauss-Jordan elimination method is a way of solving linear system of equation AX is equal to B after you reach the unique low reduced echelon form of A. then you can easily find what is the free variables and what is the leading variables. Then you can just point out the value of xi's, isn't it? Okay, that's the Gauss-Jordan elimination. You try to find the solution after you reach that RREF of A. And elementary row operation is just the ways in the process of when you solve the linear system of equation. Before, what you did, you just simplified the equations in the system to eliminate the variables from the left, isn't it? That's just the elementary row operations. Those are the differences. Got it? Okay. Book here. Here. And you also asked how these three type of elementary matrices are used. Here, we use these three type of elementary matrices, type 1, type 2, and type 3, to find RREF of A, or RREF of A, or inverse of A. Yes, instead of you do the operations, you just multiply the corresponding elementary matrix, which make much simpler. And also, in that case, you can use a computer more easily. That's just product of matrix, if you find it. So instead of doing your elementary row operations, you just multiply corresponding elementary matrices. Then all the processes are same, and which is much simpler in theory and also in computational aspect. With the property of three type of elementary matrices and the operations, and we use it for finding determinant of matrix A. Yeah, we just multiply the elementary matrices, then eventually you can get a determinant of matrix. And also, when you do multiply the elementary matrices, then you're going to have an upper triangular matrix here. And if you use those properties, then product of lower triangular matrix is a product, and the inverse of a lower triangular matrix is another inverse matrix. So you have a matrix A, which is a product of lower triangular matrix and upper triangular matrix. And so it has a lot of use. Okay, elementary matrices. And all kind questions. And simple. Okay, here. And Orkan asked why you used the determinant of lambda I minus A is equal to 0 to find the eigenvalues of A. Okay? Here, there was some errata so I fixed it here. In order for lambda be an eigenvalue of A, the determinant of lambda I minus A had to be equal to 0. Why? Not 1. Lambda, in order to lambda be an eigenvalue of A, determinant of lambda I minus A should be 0. Because if AX is equal to lambda X, and X is a non-zero vector, then we say this lambda is an eigenvalue of A, and this non-zero vector X is a corresponding eigenvector of A. Isn't it? Okay, yeah, bulk. Okay. So if this satisfies, then this can be simplified as AX minus lambda X, and X can be factored out like this. So we have this. And X is non-zero vector, because X is an eigenvector. If this satisfies, what that means is we have a non-trivial solution. If so, this determinant of this matrix should be 0. If not, we have an inverse matrix of this. If we multiply the inverse matrix of this on the left, then X should be a 0 vector, because matrix times a 0 vector should be a 0. So since X is not a 0 vector, so this determinant of this matrix should be 0. So if lambda is an eigenvalue, then determinant of lambda I minus A should be 0. So solving this determinant of lambda I minus A, which is equal to 0, which is called the characteristic polynomial of A. So you can find the eigenvalues lambda. You can find all the eigenvalues lambda from this characteristic polynomial. Got it? Okay. And yes, Quantum Magazine showed something in K-MOOC linear algebra. Yeah, this was newly offered with the support from the Department of Education for free. So yeah, if you have a chance after midterm exam, you can take a look. And yeah, okay. Here I gave us some article on the knowledge generation learning, which says how you generated the knowledge, not just memorize the old knowledges. And this is actually what you have done. You have solved your own problems, and you asked the questions, and you made the answers on it, and you edited it, you revised it, you have made your own report, and you have generated the new knowledges from not just memorized the content. You have generated. This is what we have done. And yeah, Min Jae-pil, Mr. Min asked the question, and Mr. Hyun gave an answers. Mr. Hyun, yeah, what was the question and what was your answer? Okay, now I think most of you fully understood this. So we have proved how to get this theorem 6.1.2 to find how this matrix A is defined, whose column vectors are image of standard unit vectors EIs. With this theorem, we were able to find the standard matrix of the projection with the y is equal to tangent theta x by finding the image of 1, 0 vector as a first column, and the image of 0, 1 vector E2, which is the which forms the second column of this corresponding standard matrix H theta. With this H theta, the next problem is finding the standard matrix for the projection of x onto y is equal to tangent theta x, which has the relationship like this, which is we are looking for this. This is just half of from here to here, this vector. So h theta x minus x is this vector from x to h theta x, and the vector here is from x to p theta x is can be obtained by p theta x minus x, which is half of this, which gives us this relationship. So from here we already know h theta, so finding p theta is easy. It's a simple computations. So p theta of x can be written in this way, and we know the h theta here. So just substitute h theta to have this, which can be simplified like this. That's the whole idea. Got it? Mr. Jung? Got it. Okay. And what else? Min Jae-pil. And he asked the Lagrange polynomials. He asked, but he didn't mention he gave a long numbering. So yeah, we went through the other problems, but now I found from the attached file, and he was curious about the Lagrange polynomial, which used the Vandermonde matrix to find the polynomial that passes through the point. Okay, and it was explained. I gave full details of explains in the class, and Miss Kim Ji-won. So if I give you a 100 point of xi's and yi's, can you find a polynomial that passed through that 100 point? And that is called the Lagrange interpolation. And that we did use the Vandermonde matrix, which is this matrix. The determinant of this matrix is not zero, always, if xi's are different. So if you collect the data at a different time. 1 a.m., 2 a.m., 3 a.m. So if you have xi is our different, it always this matrix is invertible. So we can easily find the solution of Vx is equal to y. Okay, Vx is equal to b. So that's the whole idea of this Lagrange interpolation. Next, chapter 4. Here, also he asked why this is true. This was by Mr. Min. Yeah. This, as you know, this you know this relationship. This is obtained since from the Cauchy-Schwarz inequality. From the Cauchy-Schwarz inequality, we know this inequality, which means there exists this value is in between -1 and 1. So there exists a theta which has the same value of this is equal to cosine theta. There exists a theta that cosine theta is this, because cosine theta moves from +1 to -1, isn't it? So at certain point of theta, the cosine theta value should be same as some value, scalar value, in between -1 and 1. We defined that theta is an angle between two vectors. Okay? Okay. These vectors can be a polynomial, and these vectors can be a matrix. So we can define an angle between two polynomials, or we can define an angle between two matrices. Okay. So with this relationship, if you just square of them, you just multiply the same thing on both sides, then you will have this, isn't it? Just this square of that formula on the angle. I think the presentation, yeah, on the presentation, and you asked, yeah, okay, you better use your, yeah, you submit your PBL report, so you know you can explain yours. Actually, I added all together, so I will briefly show what I have graded, but you can explain with yours. So you are ready, Mohammed. You did collect yours, but you don't understand what you wrote. Okay? Okay. If you understand, then you should be able to explain what you did. Here, Miss Kim Ji-yoon. Yeah, you asked, yeah, which one is bijective and injective and surjective. So do you understand? Why this? Why? So you showed this is not bijective, and why the second one is bijective? Why? Okay, now everybody understand how we show a given function is a linear transformation or not. And we can also, when we have a linear transformation, we can find the matrix representation of the linear transformation, and then we can check the determinant of that matrix to say whether it is one-to-one or onto or invertible or whatever, by using the invertible matrix theorem, which we have studied. Okay, so the second one, S, is bijective and 1 is not. And because 2 is bijective, because 2 by 2 matrix, the standard matrix is invertible. Okay. Next. 이게 아니지. 디멘전이 다르잖아. 그러니까 Rn에서 Rn으로 가는 리니어 트랜스포메이션이 원투원이면 그냥 원투지. 근데 Rn에서 Rm으로 가는 거는 원투원이라고 원투라고 할 수는 없지. Got it? Okay. So you have to check the conditions well. Next. What else? Miss Kim Ji-won, you asked some here also. Yeah. Yeah, I think it was a similar question that you had. It was already answered. Okay. And some of your discussion, of your note was not correct, so I fixed it in here. So if A is an invertible matrix, then any eigenvalues of A cannot be 0. If okay. Because of this argument. Next. Okay. So yeah, I asked you to check this random problem generator, which I had a patent on it. And here, for example, if you wanna do finding the RREF here, then suppose if it's, so this randomly generated the matrix here. Okay, if I do it again, then it will produce, it will make a new problems over and over again whenever I click it. So check whether find the RREF of this matrix. So what's the answer? Is this an answer? No. This is the answer. Okay. So here also you have covered the linear transformation in chapter 6 and standard matrix. For example, this is a linear transformation that you have. If you click it, then you will find another matrix is here. With this, my code generate not only these problems but also just they compute the answer. So when we enter our answer here, it just compare to what we put it in and what he computed, and check whether they are same or not to give us the solutions like this. Okay, here. So, Miss Choi Han-sil. So if you have a linear transformation like this, can you find the standard matrix like this? Can you? No? All you have to do is just find the image of 1, 0, 0 from a first column, find the 0, 1, 0, image of it, second column, and image of 0, 0, 1 on the third column. Okay. You should be able to do it. If you cannot do it, you cannot start chapter 7 and 8. In chapter 7 and 8, we will start from there. We will use a different basis, not standard unit vector. We will use a different basis. So it will be taught, if you cannot do that, you cannot even start chapter 7 and 8. Let's check. Can you find the standard matrix of a linear transformation? You cannot. 무조건 할 수 있어야 돼. 그러니까 함수가 주어졌어. T에다가 1000 집어넣어서 이미 구할 수 없어? 그렇지. 그러니까 선형문에 주잖아. XYG에 1000 집어넣어서 이미 구할 수 있지. 첫 번째 컬럼에 써. XYG에 010 집어넣어서 두 번째 컬럼에 써. 세 번째 001 집어넣어서 세 번째 컬럼에 써. 그게 다 알파는 다르잖아. 그걸 할 수 있어 없어? 그걸 못한다 그러면 안 되는 거야. 그걸 할 수 있지? 그러니까 이 7장 8장에서는 지금은 스탠다드 기전을 사용하잖아. 그때는 알파, 베타, 다른 일반적인 기전에 대한 매트리스 기전 기전을 배운다고. 이걸 할 수 없으면 시작도 못해. You have to understand it. You have to fully understand this first before you go further. Okay? So, Buck. You know how to find this, okay? Standard matrix. Orkan. Mohammed, if I give you a linear transformation like this, you can find the standard matrix. Easy, isn't it? Yeah. Okay. And such and such. So so yeah. You can try. Yeah, you can try those. It's a summary of this, and I think most. So now we start. We start to the notice here. Our midterm exam here. This is the midterm exam that we had 3-4 months ago in the spring semester of this year. And as I mentioned, I will give you the code. I will give you all the necessary code that you handle the problems in the exam on here. And then we will have the true-false problems. You will have, and we will have some state-defined problem like this. If the problems are small, then you will have to fill out everything. If you have the large number of problems, then I will make the small boxes so you can easily fill out. And so computations and how to explain, how you can get it, what this means and such and such. Explain. I will not ask you to prove something, but I will ask you to explain how you're going to find the solution, how you did get the solution, like this. Explain. With boxes. And for this is for example in here I asked you to suppose I give you a large size matrix like this, then I may ask you how to find the augmented matrix, how to find the determinant of the matrix and inverse of matrix and characteristic polynomial of a given matrix and all eigenvalues of matrix and all eigenvectors corresponding to each eigenvalues. And so if you have done it once, then you will understand. And just get prepared for those. And I also ask you like this. I asked you how to explain. I will check you whether you understood or not. And also I'll ask you this page once again next week. You will fill out. You will. I will give you this separate page of this, so you can before your exam you can fill out all the details this one page and bring it. I will upload this page. So after you study for the midterm examination and you fill out the number of your participations here and the important concept that you have learned and such, and bring it. It will count. Before I gave 14 points on this, okay, among the midterm exam, 100-point midterm examination. And okay, so anyway, this. So I will make. I started to make our new midterm examination, and this is a sample for you. And also, Mr. Chung mentioned in your PBL report to have our community. So you can find this in the neighbor cafe, and here. That I made it a couple of years ago. And but sometimes we used it. But so anyway, here midterm examination, your PBL report are here, and you can anyway. So if you 정군이 이렇게 Q&A 저쪽에서 Q&A 사용하는데 좀 불편하다 그랬잖아. 그래서 이 카페에서 이거를 사용하는 거를 한번 생각해 볼 수도 있어요. Okay, you can, yeah. Okay, we may utilize this cafe for not only for this semester, so even after this semester, so you can use those contents. So anyway, here the PBL report presentation. I think this is what we're going to do today. And also, Mr. Lee Dong-ho made a note on here after he meet me. So Yeah, I think this is a valuable information to improve your learning process of linear algebra in our class. Okay, now we're going to start this. Before we start, any questions? If we have what? We have a PBL report here. Okay. So yeah, we will start to go through to review the first 5 chapters that we have covered. Any questions? Okay, then we will start.